So how you guys doing? We are going to talk about verifying trig equations. And when I say verify, I'm trying to prove that the left and the right side are exactly the same. So, couple little rules for verifying. First, you can only work on one side. Not both, you pick one side. Secondly, you're not allowed to move things from the left to the right or the right to the left. Everybody's kind of stay on their own side, and I'm trying to show the two sides are the same. So, back to the first rule, so to speak, you're like, well, which side do I choose? I choose the side with all the junk on it. So in my case, this problem, I'm going to choose the left side, and I'm going to work on the left side and try to make it legitimately look like the right side. So here's my train of thought, because there's a number of different ways that you can actually get started on some of these. Some of them are quicker than others, and some are not. So depending on which route you take. So I'm going to start on the left side. And here's what I'm noticing. I'm noticing that on the right side, I need sine, bottom line. And I'm noticing this says cosine. Now I've got tan and cotan. So I am going to rewrite tan and cotan in terms of sine and cosine, since the rest of the equation's in sine and cosine. So when I do that, this is going to be the sine of u over the cosine of u. And I'm multiplying it by cotangent, but cotangent can be rewritten as the cosine of u over the sine of u. Minus cosine squared u equals that side. Good? Okay. And now I'm noticing when I look at these two fractions that we're multiplying, I'm like, it looks like the cosines will cancel, the sines will cancel, and I'm left with just 1. 1 minus cosine squared of u, and it's supposed to equal that side. Y'all with me? Okay. Now, my brain, at this point, when it sees a trig function squared, it goes to one of the Pythagorean trig identities. 99% of the time, I'm going to use one of those identities when I see a trig function squared. In this particular case, I see cosine squared. And I'm remembering there's a Pythagorean trig identity that says cosine squared plus sine squared equals 1. Now, it's an equation, so I can rearrange the equation any way I'd like. And since this says 1 minus cosine squared, I'm going to minus the cosine squared on both sides. So I get sine squared equals 1 minus cosine squared. I'm going to make that substitution. So I'm going to substitute sine squared in for 1 minus cosine squared u. And that equals, lo and behold, sine squared u. This is the very last line where you actually have the exact same thing written on both sides of the equal to sign. Verified? Check. With me? Okay. I have got some examples coming your way. Work on them before you find my lecture video. Or I should say before you find my answer key video. Catch you guys on the flip side.